So as EV ecosystem is expanding, cybersecurity has become even more important. And to address this topic within the EV ecosystem, we have Gilles Chèné, the business developer at Thales, which comes with more than 15 years of experience and will address the risk and priorities within the EV charging infrastructure. Please, Gilles.
Hello, good morning. So I am Gilles Chèné. I am doing business development in Thales. So I will do a quick overview of what Thales is doing, and then I will explain why cybersecurity is a must in this ecosystem. So Thales, it's 81,000 employees in the world. We are present in the 68 countries. We are investing 4 billion euros with 1.1 billion euros in R&D. We have 18.4 billion of revenues, and we are organized in 3 marketing segments. So one is the airspace, one is defense and security, and one is dedicated to digital identity and security. And this is in the last one at the bottom where the smart mobility vertical is present. In this vertical, we develop connectivity and cybersecurity solution for our customer, helping them to connect and cyber secure their product. We have a lot of customers, cities, enterprise, governments, institutions. So today we will talk about cybersecurity. Hacking in EV charging is a reality today. We saw some publication disclosed by hackers or researchers on the risk to have cyber attacks on the ecosystem, either on the charging station itself, either on the back-end systems. So we will have some example at the bottom of the slide. So more and more devices are connected today. The attack surface is increasing, and then cyber attacks are growing also. In 2021, the increase of cyber attacks was around 300% on critical infrastructure. So this is a fact. And 4.7 million euros was the average cost on cybersecurity attacks on the energy sectors. So it's very important. One report from upstream mentioned that EV charging attacks represent 4% of the smart mobility incident in total. So attacks can lead to data breaches, fraud, denial of service, and production interruption. There is different types of attacks. Unauthorized access on the charging station, on the charging station management system, on the cars. There is malware and ransomware also attacks by taking control of the charging station, for example, by injecting some malware within the charging station. We have also network attacks by using botnets in order to generate deny of service on the charging station and on the backend systems. We have also firmware and software vulnerabilities. So we need to pay attention to update regularly the software of the charging station, some operating system layers. And finally, physical attacks. So the hackers is in front of the charging station in order to take control on the software. So in terms of example, we saw hackers, Ukrainian supplier of charging station hacking the charging station on the field in order to disrupt the service of EV charging. We saw some hackers injecting some inappropriate contents on the screen of the charging station also. More recently, you heard about the QR code sticking on the charging station as a phishing attack in order to take banking card information of the user and perform some payment. So lot of incident, I will say, in regards of the EV charging ecosystem and attacks. So for the time being, it's not so strong, but because more and more EVs will be deployed and charging station will be deployed, the incrementation of attacks will come. So there is different challenges for cybersecurity. First is political. States and governments must keep sovereignty on their critical infrastructure. So the energy network is one of the critical infrastructure. But also to succeed in their engagement, ambition to move to zero emission with EV deployment. They need protection of the infrastructure and the trust of the citizen in this infrastructure. The risk can be economical also for all the stakeholders of the ecosystem. The charging operators, the user themselves, and also the aggregator. I heard recently that researchers demonstrate that it was possible to modify the charging profile in terms of user preference in order to change the consumption of the energy on the network. So that can have two impacts. One is to load the network, the energy network. And the second is also to have an impact for the aggregator according to their engagement with the energy market. Technically speaking, as said by my previous colleagues, there is a lot of actors, entities in this ecosystem, and it's very complex to deploy the security in these old entities in order to make the trust between each of them. Also, the charging stations are connected to critical and vital infrastructure, so we need to pay attention of the security, the cybersecurity that will be implemented in these devices. We have also to pay attention about the lifespan of the cars and also the charging station. They are on the field for several years, so it's very important to plan, to be able to renew, to patch the software, and to renew the certificates. So the standards, the ISO 15118 and also CPP, take into account of this capability to upgrade the charging station on the field. Finally, the last challenge is about regulation implementation. So yes, thanks to the ISO 15118, we have the rules in order to install the trust between all the entities. But there is also the Cyber Resilience Act that is mentioning the duty of all the stakeholders in the chain, the charging station manufacturer, but also the distributor, the operator that will manage the charging station on the field. And if there is some issue by following these rules, some penalties will be applied to the stakeholders. So it's very important to take attention of that. So how to protect the EV charging ecosystem? So first, we have to apply the security by design approach. meaning that starting with a risk assessment in order to identify the potential risk, the potential attacks and vulnerabilities of the charging station. But not only the charging station, there is also the CSMS, the Charging Station Management System. We have to consider the full system and then having a focus on the subsystem. Charging station is a subsystem. The Charging Station Management System is another subsystem. So on top of this risk assessment, we will be able to design a secure architecture that will integrate the security basics. We have also to take attention about the privacy protection in order to protect the user of the data that will be in the charging station or the charging station management system. And also to be sure that only the dedicated data will be managed and not the unnecessary one. We have also to pay attention of the access control. It's very important to implement a strong authentication, mutual authentication between the different assets in order to avoid hackers to take the control of the system and inject malware or modify the software, modify the settings of the charging station. We have to pay attention about secure communication. The charging station is connected to different networks, cellular networks, to the CSMS, or via Bluetooth, via Wi-Fi, connected to a smartphone, for example. So it's very important to protect the communication by using a secure protocol, so TLS protocol, HTTPS protocol, between the charging station and the backend systems. Finally, as I already said, pay attention to regularly update your software, deploy patches according to the evolution of the operating systems. And finally, you can also implement intrusion detection software in order to monitor the activity of your charging station, in order to detect abnormal behavior of your charging station, and then take appropriate actions thanks to a system that will operate on the back-end side. So ISO 15108 relies on PKI framework. We already discussed about that, to provide trust and secure the full ecosystem. So it's a good thing. So as Thales, what we are providing in order to help to secure the ecosystem. So first, we are delivering consulting for cybersecurity, helping, supporting on the different standards and regulations. We are performing with our partners and customers the cyber risk analysis. We are also writing specific recommendation in order to design a secure architecture. And we are performing pen testing in order to validate that the recommendation and best practice are well implemented in the product. In terms of assets, we are providing secure hardware and software. So we have a secure element, so it's a secure chip, tamper-resistant chip that will be soldered in the device in order to provide secure storage of keys and certificates, managing algorithm cryptographic operation also for verification of the signature. And we are able also to bring a specific piece of software in order to make a robust access control. We are also providing threat detect and response solution. So it's a software probe that is installed in the charging station in order to monitor the activity and detect the attacks, connected to a backend with artificial intelligence and machine learning in order to analyze the data and generate alerts for operators to trigger some action to, for example, stop the charging station. We are also providing a solution in order to help to secure the identities that will be deployed in the cars, in the charging station. We are able to generate certificates also and to download these certificates in factory in order to bootstrap the charging station with the security identities. And also being able to do such things during the life of the charging station as soon as deployed on the field. So these certificates have an expiry date, so it's possible, thanks to this solution, to renew or to revoke the certificates. So I'm done. So if you have any question. Thank you.
Okay, I have one question.
Okay.
So, how much can we reuse from the tools of cybersecurity coming from Internet of Things IoT in the case of electric vehicle charging infrastructure?
Yes, indeed. Actually, IoT devices are connected to the network, so it's very important to inject at the manufacturing of the IoT device certificates, public keys, in order to provide a secure digital identity of the device. Having this security identity, the device will be then able to be authenticated by the backend and create a trust between the device and its backend. So the tools that are used for any IoT device can be reused for the charging station. Charging station is one of the IoT devices that we know.
Okay. Any other questions?
Yeah, it's my question would be very, very specific. Within you, because you have mentioned the global the global world on which we have electric vehicle and charging points, but I wanted to refer to the public transportation market, and where today most of the equipment which are purchased by public entities. So they have the capability to ask or to ask for their suppliers to take in charge the cybersecurity requirements. And within the regulation today, which type of tools do they have in order to oblige their suppliers to implement this type of cybersecurity obligation that you have mentioned? That's my first question. And my second question: to which extent you, as consulting company, or how could you help these public entities in order to implement this type of obligation? Because you have mentioned how you could help the industry and suppliers, but my question was a bit more specific. How could you support and help the public entities which will have to purchase this type of equipment, and more specifically for public transportation?
Okay, there is several questions in one, I will say. So first, it's important to comply with the regulation. So regulation is bringing rules and duties. So companies that are creating the device have to follow such. Either they have their own cyber security experts and capability to design and implement the best practice, I would say, to secure the device, and it's good. Otherwise, they have to rely on companies that are expert on cybersecurity in order to help, to support. It's better to think about that, to think about cybersecurity at the design of the device, of the product, in order to integrate cybersecurity requirements and methods in the fundamental layers of the product. Then, so this is for the manufacturer itself, and then for the users, they need to ask a guarantee of the manufacturer that he did the things in a good shape. Otherwise, it will be the responsibility of the manufacturer and the one that is operating the device, selling the device, to manage the compensation. We are able to perform some analysis post-production, post-manufacturing of the device. We perform penetration tests, for example, in order to assess finally what could be the resilience of the device in front of cybersecurity attacks. So this is something that we can do afterwards for a customer willing to assess the security of a device that has been already deployed on the field. Did I answer to your question?
Okay.
Okay, last question. Yeah, I mean, yes.
Go.
We are talking a lot about second life equipment on recycling. Are there any things or preparation for this topic in the safety security area?
Yes. What I am seeing is about the change of ownership of a device. So as soon as the device is remaining in the same form factor than its first life. So in this case, thanks to PKI, once again, it's possible to update the certificates that will be generated or trusted by another certificate authority. So if the owner, so one example, it's not exactly about second life. It's just, for example, the change of the CPO that will operate a park of charging station today. He has a contract for 3 years, and after these 3 years, this is not the same CPO that has been selected to continue to operate this. So thanks to PKI, it's possible to download within the charging station certificates dedicated or owned by the new CPO. So this is a way where we are managing the change of ownership. For devices that will leave one activity to a new one, this is the same thing. In terms of security mindset, I'm just talking about cybersecurity. So we change the secure identity of the device between the first life and the second life. It can be also something that we can apply to the battery. In the battery, we may have certificates belonging to the car OEM, for example. And after that, if the battery is used for another usage, it will be possible to onboard in the battery new certificates in order to prove the ownership of these new operators or owners.
Okay, thank you, Gilles, very much.
Thanks
for
a
the
lot.
presentation.